All right, welcome to the Explainer. Today we're tearing down a keynote from CES that's, well, it's not just predicting the future, it's saying the whole thing needs a complete do-over. Let's jump right in. Okay, let's start with this quote because it really sets the stage. The keynote kicked off with this massive idea. We're not just seeing an upgrade or an evolution, we are living through a fundamental reset. I mean, think about the jump from mainframes to PCs or from the internet to your smartphone. We're talking about that level of change, a total reset. And this right here, this is the core of it. The old way, we programmed computers. We gave them very specific step-by-step instructions. Now we train them. We let them learn. And the engine driving all this isn't the CPU anymore. It's the GPU. Applications aren't these static things we install. They are literally being generated, pixel by pixel, token by token, in real time. It's a completely different universe of computing. Okay, so a reset sounds big, but what does that actually mean? What does it look like on the ground? Yeah, it's not just about some cool new app. We're talking about the whole thing. The keynote called it the 5-layer cake of computing, and every single one of those layers, from the silicon at the very bottom to the apps you and I touch at the top, is being rebuilt from scratch for AI. All right, so if you're rebuilding the entire foundation, what kind of new house can you build on top of it? Well, it turns out you can build a totally new kind of software. And that software is what they're calling agentic AI. Now, this is a huge leap past the chatbots we're used to. We're not just talking about something that answers your questions. We're talking about an AI that can actually understand a complex goal, reason about it, go out and do research, and even use other apps and tools to get something done. These things are active problem solvers. And just look at the thought process here. This is what makes it so different. An agent doesn't just give you a pre-programmed answer. It reasons. It figures out what it doesn't know and then goes and researches it. It looks at the tools it has, other apps, APIs, and uses them. And only then does it come up with a plan and act. That's how it can solve problems it was never, ever explicitly taught how to solve. And the framework these things are built on is just, wow, it's incredibly flexible. It's multimodal, right? So it gets text, images, speech, all of it. It's multimodal, meaning it can call out to a bunch of different specialized AIs to pick the best one for the job. And it's hybrid, so it can run in the cloud or right there on your device. It's basically a system that can pull in whatever resource it needs from wherever it is to solve the problem. Okay, so that's the software side of things. Pretty amazing. But how do you get all that intelligence to work in the real world? Our messy, physical, unpredictable world. And that is the billion-dollar question, right? How do you teach a robot common sense? I mean, stuff we take for granted, things we learn as toddlers, like gravity, things fall down, or object permanence. Just because you can't see something doesn't mean it vanished. For an AI, none of that is a given. So here's the big insight. If you can't get enough data from the real world to teach an AI all those things, and you never can, there are just too many possibilities, then you have to make your own. You have to literally turn your computing power into data. And that's exactly what something like Cosmos, this world foundation model, is designed to do. It just generates endless, physically realistic synthetic video. This is a game changer. It lets developers train and test things like self-driving cars or robots in a perfect simulation. They can cover millions of bizarre edge cases that would be way too dangerous or just flat out impossible to find and record in the real world. So, we've got this super intelligent software. We've got AI that can learn about the physical world. But to actually power all of this, to train these absolutely massive models and run these insane simulations, you need a whole new kind of machine. You need the engine of the future. And here's why it's so urgent. The size of these AI models, it's not just growing, it's exploding. We're talking 10x bigger every single year. The demand for computation is on a curve that makes Moore's law look like a flat line. The industry is basically about to hit a brick wall. So the solution they came up with was, well, it was radical. They called it extreme co-design. Instead of just upgrading one part of the system, they threw out the old playbook. They redesigned the entire stack all at once. 6 brand new breakthrough chips, all built from the ground up to work together as one single system. Let's quickly run through them. First up, you've got the Vera CPU. Its whole job isn't general-purpose computing. It's designed to be a fire hose for data, just feeding the rest of the system as fast as possible. Then you have the heart of the beast, the Rubin GPU. This is the engine. This is what does the absolutely brutal number crunching for AI training and inference.
But one GPU isn't enough. You need thousands. That's where the Connects 9 comes in. It's the super fast networking that lets all these GPUs talk to each other, essentially turning a whole data center into one giant brain.
Then you've got this clever little chip, the Bluefield 4. You can almost think of it as a computer for the computer. It handles all the boring but essential stuff, storage, security, networking, so the GPU can focus 100% of its power on doing AI. And inside each box, the NV-Link switch is the magic glue. It lets up to 72 of those Rubin GPUs act like they're one single, massive, unified processor. It's incredible. And finally, to connect thousands of these machines into a true AI factory, you have the Spectrum X Ethernet. This thing actually uses silicon photonics. It sends data using light to link everything together across the entire data center. And this is what it all adds up to. This slide really drives it home. Look at the before and after. You go from a system that took 2 hours to assemble with 43 messy cables to a clean, fully liquid-cooled unit that you can literally snap together in 5 minutes. That's what happens when you design the whole thing to work together from the start. So, after all that incredible engineering, what's the payoff? The numbers are just mind-blowing. AI training is 4 times faster. The throughput of an entire AI factory goes up by 10x. And maybe the most important number of all, the cost to generate a single AI token drops by a factor of 10. This isn't just a small step up. It's a giant leap that changes the economics of AI. So you take it all together, from this new kind of agentic software that can think and plan, to physical robots that learn about our world in these simulated universes, all of it powered by this brand new type of AI factory. I mean, the fundamental building blocks for the next decade of technology have just been completely reinvented right in front of us. This is the engine. And the only question left is, what are we going to build with it?